Okay, today is our last section in topic 3. It's symmetry. We're going to talk about rotational symmetry as well as cutting things, the symmetry that you're used to as well. Okay, so a figure has symmetry.
Where's my pencil?
Symmetry, if a rigid motion can be mapped to the figure, if a rigid motion can map the figure onto itself. Okay, so you've done horizontal symmetry, you've done vertical symmetry, you've done those kind of things, but we're also, like I said, going to move on from that. So reflectional symmetry. Reflectional symmetry is the symmetry for which a reflection maps the figure onto itself. A line of reflection for a reflection symmetry is called the line of symmetry. So the first bullet here describes the reflection of R of M and R of N. Mapping the figure onto itself, observe that there is a line M and N. Both divide the figure into two pieces. I can do M, which is a vertical line through the center, and I can do N, which is a horizontal line through the center. And that's how you would describe that reflectional symmetry. You would say reflectional symmetry of a vertical line through the center and a horizontal, I would say vertical and horizontal line through the center. You have to just say it's reflectional symmetry, and you have to say vertical, horizontal, and where does it go through? Because it could go through the left or the right. A figure has rotational symmetry. That probably should have been a fill in the blanks. You might want to underline that. If its image is mapped into the pre-image after a rotation of less than 360 degrees. Okay, 360 degrees doesn't count because that doesn't change anything, right? I turn all the way around. Rotational symmetry can be 30 degrees, 120 degrees, anything less than 360 degrees if I turn this. And this is over a point P, which is in the center there. So this rotation would be 180 degrees about P. If I turn this thing 180 degrees, does it get right back to where it was? Yeah. What about if I turned it 90 degrees? Would it be where it was? No, because we straight up and down, so it'd have to be 180 degrees. But again, it has to be less than what? 360. Because everything has rotational symmetry about 360, doesn't it? Yeah. So we're looking for specific ones. Okay, so what transformation map maps each of the figure to itself? Now, hopefully you don't have this box around yours, but evidently I do. Okay, so we're going to talk reflectional first. Is there reflectional symmetry here?
Yeah.
Yes. Okay, so I would write reflectional. Over. What kind? Do they have vertical, horizontal, diagonal?
Both.
Yeah, vertical and horizontal, right? Over vertical and horizontal lines through the center. Do I have a diagonal? Can I do a diagonal one here? No. If I had it, I would say through the vertices or whatever, right? Okay, what about rotational?
Yeah.
How many degrees do I have to rotate it before it's back on itself?
180.
180. Okay, so I have then rotational.
I do not have that much.
You're gonna have to right on the side. Okay, rotational 180 about P, and P is where? In the center. P is the center. Point P is the center. Rotational symmetry is at the center.
Oh God.
Okay, so we have a smiley face.
There's one. Oh.
Do I have any
Line of
reflectional?
Yeah.
Where?
Down the middle.
Down the middle? What way? Horizontal, vertical?
Vertical.
Okay. Anything else?
No.
May you please move, Mrs.
I
Wade?
am. Okay, I can't do, this is not, if I drew this, I'm good, yes? But if I do horizontal, does that reflect itself? No. If I took the face off of it, could I do horizontal?
Oh, I see, yeah.
Yeah, but with that face, I can only do vertical, right? What about rotational?
No, do rotational whole 360.
But it has to be less than what?
360.
Less than
Couldn't you
360.
do, like,
It is less. It's just the same.
No, 360 is 360. Rotational symmetry is only less than 360.
That's the same when you rotate it.
1 degree?
Okay.
So we don't have to put anything about 180p or anything?
No, because there is no rotational symmetry less than 180. Rotational symmetry at 360, less than 360 doesn't count for rotational symmetry because everything can be rotated 360 degrees and be the same.
Then how do you get the rotational 180 on the other one?
Well, because okay, if I turned it 90 degrees, I'd be here. Is that exactly the same picture? No. So I'd have to go a whole what? 180.
No, I got it.
To get that face back, it would have to be, because it would be, oh.
Okay, so example of identifying lines of symmetry. So how many lines of symmetry does a regular hexagon have? Well, I can go through each of the vertices, correct?
Yeah.
Okay, so I have 3. So I have 1, 2, 3. Yes? Do not count both ends. That's an error that a lot of people will make. They'll
What
count like
ends?
both ends.
Which ends?
Like this end and this end of the same line.
Oh.
Okay? Now, can I cut it anywhere else?
Yeah.
Yeah, down the middle.
I can do it down the middle here,
Couldn't
but
you?
I could do it here and
I was
here.
just kidding.
so I have 3, 4, 5, 6.
Technically, couldn't you do that for like infinite?
No. 'cause
No.
it has-
Because you're looking for symmetry and it won't. Because I go off of those centers and it's not symmetrical.
Okay.
I've got to be able to like folding it and it goes right on itself.
Alright.
Okay? So this one has reflectional symmetry, yeah?
Yeah.
How many degrees will I turn it to get it this to be here?
45.
45? How'd you get 45?
No idea.
Oh,
It just looks like a
oh,
45
oh.
degree angle.
You're here.
Well, how many
Oh,
how
wait,
many
because,
vertices? How many vertices do I have?
Sorry, you guys can't have this. Dude.
wait.
6. Okay, how many degrees are in a full circle?
360.
360. So for me to figure out what this has to be to map it right there, I would take 360 and divide it by what?
4. 6. How many
6.
sides?
How many vertices there are?
Up to
Okay.
60.
So then it would be 60 degrees. So I could turn it 60 degrees and be the same. Then I can turn it what?
60.
60 more, which would be what?
120.
120. Then I could do it 60 more and it'd be 180. Every time I'm adding 60, right?
Yeah.
And then do it again and it'd be what?
240.
240.
The 300.
And then 300. And I would stop at 300. Why?
Because you can't
Yeah.
have 360.
It just less than 360. So rotational symmetry is 1, 2, 3, 4, 5. It had one less than what? the number of sides, didn't it?
So
Now,
the answer
does-
would be 60?
No, it'd be 60, 120, 180, 340, and 300 for rotational. Because I can keep turning it and keep mapping it to itself, can't I?
Uh-huh.
Now, again, you've got to stop less than 360. Now, does this work for every shape? No. It works for those regular octagons and hexagons and those things. How many lines of symmetry do we have in each of these? I want you to do them on your own. And I want you to describe them. How many lines? I just want the lines of symmetry. Like we did horizontal, vertical, through the center.
What if you can go like a bunch of different ways?
If you can go a bunch of different ones, you gotta find all a bunch of them.
I have 6 ways.
I've got not 6.
I don't have 6 on the rectangle.
No, let me
I'm
see.
just-
1, 2. I got 4 ways.
Okay.
No.
Well,
That's
we'll
wrong.
have a debate in a second. I
That's
want everybody,
wrong.
That's wrong.
That is wrong.
gentlemen.
Actually, it's right.
Okay, do everyone have both?
Yes.
Yeah.
Okay. Well, we know Carly has 4. How many you got?
3.
3. How many you got?
One this way and one that way.
So, one this way and one that way. That's
Yeah.
all I got.
I got
You can't go diagonal because it's not equal
Why
sides.
can't
That's
I go?
right.
Why can't I? Why can't I go diagonally?
Because
If you try to, oh, hey,
add them up if you want to know their
If I fold
a
this
piece of paper.
your piece of paper diagonally, does it map itself to itself? No. So there are how many? 2, 1 horizontal, 1 vertical through the center. So be careful. Be careful on saying I got
That's all
more.
we have to do. Right, 2.
With 2, 1 horizontal, 1 vertical through the center.
Do we have to write reflection?
Yes. Or, well, this is lines of symmetry. So 2 lines of symmetry, 1 horizontal, 1 vertical through the center. Okay, what about B?
There's 4.
1.
4.
It's
One.
1.
That's
one.
some bullshit.
It's vertical. That's it.
1 vertical is it.
Why can't you go
It's
across
only
though?
one.
Okay, if I go across,
The
Oh
top
no,
and the
never
bottom.
mind. I got it.
Okay, so I have to visually think about what's happening, don't I? Okay. So, and if you're working on your assignment, give yourself a rough sketch of it on your paper, okay? You should be able to draw this picture reasonably well, right? And think about it if I fold it. I just took my paper and I would have been messing with it, okay? Use some tactile things if you need to.
So the next one would be 1 line of symmetry.
Vertically through the center. Yes, 1 line of symmetry vertically through the center would be the last one we just did. Okay, rotational symmetry. Rotational symmetry has to be less than what? 360. I have 3 corners, yes?
Yeah.
Okay, so I have 360 divided by what?
3.
3. Okay, and it tells me it's an equilateral. What does equilateral triangle mean?
It's equal.
All the sides are
That's
equal.
All the sides are equal. If all the sides are equal, what are all the angles? The same
Same.
also. Okay, so I would take 360 and divide it by 3 and get 120 degrees. So if I rotate B to A, I would get 300. Yeah. Now, guys, would this work if this wasn't an equilateral triangle?
No.
No. You have to think about what triangles you have. Okay. Can I do this again?
Yeah.
Can I do another 120?
Yeah.
Yeah. So that would be what?
You're 240.
240. How did I get 240?
Yeah.
120 plus what? 120. Can I do it again?
Yeah.
No.
Because it equals 360.
One more would be equal to 360. So no.
So then you just put 120.
120 and 240 are your rotational symmetry. Now, This one is not the center. Well, yeah, it is the center. Never mind. Okay, parallelogram. What's its rotational symmetry? You can't do 360 divided by 4. Why not?
Because the sides are
The sides aren't equal. So if I turned it 90, would I be good?
no.
I got to keep going to what?
180.
180. So it's 180 degrees over point P, and point P is in the center. And I didn't put P over there, but that's okay. So the rotational symmetry is 180 degrees. So on some of these, you're just going to have to visually think about what it's doing rotating around. Is there a whole lot of work to be doing there here?
No.
No. But can you show me like this
Yeah.
and this? I expect to see little work. Okay. The type of symmetry for which there is a rotation of 180 that maps a figure onto itself is called what?
Symmetry.
Oh, the point. The type of symmetry is called
Point P.
point of symmetry. Sorry. So, this would be a point of symmetry, yes?
What?
The rectangle would be a point of symmetry
Yeah.
because I rotated about that point. So what are the rotational symmetries of each? And does each figure have a point of symmetry? Because sometimes it's not the middle. Sometimes it's not the middle. Okay, so what can I do with this?
Go across, or
Wait,
I thought we were doing lines.
We're
first,
just
right? My bad.
rotational
You
symmetry.
Yeah, wouldn't it be the 360 divided by?
Well, your picture looks better than mine. Look at your picture.
Yeah, so you
Is this
take-
all the same? Are all those the same?
Yeah.
Okay,
you
so I take 360 and divide it by what?
divide by 4,
Four,
which is
Because they're all the same, right?
yeah, which is 115.
Which is 90.
Yeah, wait. Yeah.
Wait.
I forgot.
Okay, so the first one happens at 90, yes?
Yeah.
Yeah.
And then what?
180.
So 90 plus 90. So 180. And then
270. I mean 280.
180 plus 90. No, 270 is right. Is 270. Does it have a point of symmetry? Is this about the middle?
Yes.
Yes. So it's 90, 180, 270, and point of symmetry. Oh, I forgot my E. Sorry. So there's 4 answers there. 90, 180, 270, and what? Point of symmetry. Now, I think all the questions will ask about lines of reflection as well. Do I have lines of reflection here?
Yeah.
Yep, where do I got it?
Horizontal. and
I got horizontal and vertical. Do I have it diagonally?
Yeah.
I do have it diagonally and diagonally. So it has how many lines of symmetry? 4 lines of symmetry. Okay, so you need to think about all the options you have. Okay? Okay, next one. Well, it's an oval, right?
Yeah.
So
180.
180 is the only option I have, isn't it?
Yeah.
Okay? So 180, does it have a point of symmetry?
No.
Yeah.
Yeah, the center, right?
My bad.
So, and point of symmetry. Bless you.
COVID.
How many lines of reflection?
2.
2. A vertical and a horizontal through the center. Now I don't have, does anybody know a shape that you would have infinitely many lines of reflection?
A circle.
Circle. Wouldn't you?
Wait, how would it be infinite?
Because a circle,
Well, we'll have to stop eventually.
Yeah,
because,
it'll
like,
have to
you can't-
stop eventually.
no, because technically, theoretically, you can always divide a section in half. So your
Yeah, but
sections would
but
get,
if you draw a circle and you start drawing lines, you could go down to like a point of a millimeter and even though there, but you would get so far down.
right,
that
but,
it would run
but
out.
theoretically, you can always keep going.
Then you
Yes.
zoom in on it. with
And
the
you zoom in and you
microscope.
can get it again, and you zoom in and you can get it again.
Yeah, but you would
Theory-
go down to like
No.
point.
Okay, let's get
Shut up.
No.
Shut up.
Theoretically, you
You're
can
wrong.
always divide two distances in half continually for infinite amount of time. So now, physically, can I do that with a pencil? No. But theoretically, if I took like on a calculator and I kept zooming in and zooming in and zooming in, I can continually find a space to put another line in there.
On a calculator.
A calculator or computer. Yeah, my graphing calculator will zoom in. It won't do that for infinitely, but it will like a computer program. Okay, determine symmetry. Okay, so what type of symmetry does each of these have? So we've got
Point of symmetry.
has a point of symmetry. Everybody see that? Has a point of symmetry.
Reflection.
Now, it has reflection through how many lines of reflection?
1.
1, 2, 3, 4, 5, 5.
5?
Yeah.
Because I have one through each of the petals, right?
Yeah.
Okay? And then that's basically it, one through each of those petals, because we can't divide it anywhere else, can we? And they don't run, it's not like I'm going through this petal and then hitting another petal, am I? So there's 5 lines of reflection. And what about rotational?
Yeah.
How am I going to figure out my rotational?
360
360
divided by 5.
divided by 5, because every time I go, it's the same, right? So 360 divided by 5. So 5 goes into 36, 7, right? Carry a 1.
72.
Okay, so 72 degrees. And 72 plus 72, right? 144. And then 144 plus 72 would be 6, 1, 216. If I added right. Can I keep going? I'm
Yeah.
still less than 360, right?
Yeah.
Now, if the next one's bigger than 360, I just erase it, don't I?
Yeah.
Okay, so then 216 plus 72 again. So I have
288.
288, so I'm good, right?
So then the next one.
The next one's going to be more, isn't it?
It's gonna be, yeah.
So it's going to be 2, let's check it out, just make sure, right? 288 plus 72 would be 0, 6, it'd be what? 360, so that one doesn't work. I've got 5 petals, how
Where'd
many
you get
rotations could I do?
72?
4.
Where'd you get 72 from?
I took 360 divided by 5, because there's 5. Okay, what about this one?
Just a point, right?
Okay, yours is a rectangle. Mine looks like a what?
It's the same thing.
No, my picture
Oh,
does not look like a rectangle.
Yeah,
It looks like a
ours
what?
is square.
But yours is not, right? Yours is a rectangle?
No, it's
It's
the
square.
squares.
No, the whole thing.
Oh,
Yeah.
yeah.
Okay, because it's talking about the whole thing. Okay, so my whole thing looks like a square, but it is a rectangle. Yes. Okay, that changes it, correct? If it's a rectangle or a square. Okay, so does it have a point of symmetry?
Yeah.
Yeah.
So what are the other 2 points for?
Just
Oh,
to add it instead of just 2 squares. They just have 2 points. Okay, point of symmetry. Okay, because I would have to, what is the rotational symmetry here? 180. Because since they put the points on there, right, I would have to do 180 degrees to get here. If they didn't put the points on there, could it have been 90?
Yeah. No.
No, because you have a rectangle, right?
Yeah.
Okay, mine looks like a square. Could have been 90.
Yes.
And what about reflections? How many lines of reflection do I have?
0.
I have 0.
Your circles would be off.
Right. I had 0 if I took the red dots off. Could I have lines of reflection?
Yes.
Yeah, I could have horizontal and vertical. But with those red dots, can I have any lines of reflection?
No.
No. Last thing we're going to do is, what symmetries does a square have? So draw yourself a square. Ooh, that's doing good. Oh, it's landed. That's okay. Okay, square. So, how many lines of reflection do I have?
4.
1, 2, 3, 4. Okay, so 4 lines of reflection. Rotational.
90, 180, 270.
Does everyone know how 90, 180, 270? Because you're taking this vertice, going there, yes, there, and there. All I have to do is 360 divided by what? 4. And so I know they're multiples of 90. So rotational is 90, 180, 270. And does it have a point?
Yes.
Yes. I understand that. So are you just going to have to think about what the pictures you're seeing?
Yeah.
Yeah.
That's basically it today. Okay? So if you notice, guys, I want to talk about the board real quick. Today we have symmetry. We're doing one day on it. That's it. I think that's all we need. Tomorrow in class, we're going to do a Math Excel review. It's 30 problems. I do not expect you to have it done all in one day, because if you look, you have Thursday. But you do have a homework assignment. It is 3, I think, I didn't finish. I need to check. I think it's 24 through 26. I need to check that real quick. There's only 3 problems like on each section. The 1 through 10, that's like vocabulary. Okay, we need to know our vocabulary. So tomorrow night, I expect you to do that review at home, because what are we going to do on it Thursday? We're going to go over the book review, and then you're going to have time to finish the Math Excel in class. Got it?
What?
So we're having 2 days in review. Our test is on Thursday. You need to make sure that you bring a highlighter, or you have already highlighted those rules in like 3-1. The rules for reflecting over the x-axis, the y-axis, the y equals x line, right? We need to have all those right handy in our notes so we can find them, because that's what we need. Okay? So go ahead and get busy on your book assignment.
So that's
There's
all
not a
homework for
whole
today?
lot. There's not a whole lot of